All right, for this video, we're just going to recap some of the slope field stuff with 7.3 and 7.4. So we'll get into it. So in case you missed it, slope fields are basically the full graphs for the diff EQs. When we made the sign charts with the XY, we did our sign charts in those dimensions, that kind of led towards what we were doing for the slope fields. Here we don't just want the sign, we want the actual slope, so we're going to put a little slope in to represent what that slope is. So if I've got the equation f prime of x equals x, what we can do is we can find out what happens at each of our values for x. So if x is 0, f of x is going to be 0. So if x is 1, f of x is also going to be 1, 2, 2, and it kind of makes sense. So whatever we plug in for x, that's what we're going to get for our result back. So what we want to do is at our point, 0, 0, we're going to have a nice little slope of 0. When we're at the point 1, 1, we're going to have a nice little slope of 1. 2, 2 would be a slope of 2. If we did negative 1, we should get negative 1 back. So our slope would be negative 1. Same deal if we did negative 2, we should get negative 2 back. We get a slope of negative 2. And the important thing is to realize that this only depended on x, which means that in addition to all of these, every single x value is going to have the same slope. So whenever x is 0, f of x is 0. So it's not just at 0, 0, but x is 0 here, 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 x is 0 here. Likewise, these are all going to have a slope of 1, which is kind of like a 45-degree angle. These all have a slope of 2, so it's a little bit steeper. These are all negative ones. And these are all going to be negative 2s. So that's our basic thing of what a slope field is going to look like. And we kind of know that makes sense because if the derivative is x, that means that we probably should have a parabola. And if we kind of follow it, it kind of looks like it's a parabola. So it looks like that's pretty good. Then we get into a little bit more complicated ones. Now we've got x and y together. So what we have to do is we're going to have to find, not just for x, we're going to have to find out for our coordinate pair x, y, what our value of y prime is going to be. So if I pick 0, anything, I should get my y value back. Because no matter what I pick, if I pick 0 and then 1, I'm going to get 1 back. If I pick 0, 2, I'm going to get 2 back. So I want to make it a little bit nicer. I want to kind of start using some logic and some structure to say, okay, well, if the x coordinate is 0, I'm just going to get a slope of whatever the y coordinate is. So here it would be 0, 0. Here the y coordinate is 1. So try to make it 45. Here it's 2. And here it's 3. Likewise, here it's negative 1. Here it's negative 2. And here would be negative 3. So we can kind of fill out this axis. Next, we're going to check out the other axis. And it turns out, again, if we pick any number, but the y coordinate is 0, our slope is going to be x. So here x is 1. Here x is 2. Here x is 3. Here x is negative 1, so that's a negative 1 slope. Negative 2, negative 3. So those are some pretty special points, so we want to kind of look at that. The other thing we want to do when we're looking at our structure is to try and find relations. If x is x and y is negative x, we should always end up with 0, which means anytime x and y have opposite signs, we should end up with a slope of 0. So that's going to be along that diagonal right here. Because we got 1, negative 1, negative 1, 1, or 1, negative 1, we would add up to a slope of 0. So again, we can use some more logic and say, well, whenever they're the same, we should get a slope of double whatever the x coordinate is. So since this is 1, 1, we should get a slope of 2. 2, 2 should give us a slope of 4, and 3, 3 will give us a slope of 6. Likewise, if here we've got -1, -1 plus -1 is -2, -4, -6. So we're starting to see, okay, there's some different patterns that we can use. We don't have to keep plugging in the x value and the y value. We can start looking at the structure in order to shorten things up, make things a little bit easier on ourselves when we make our slope field. Now again, you can fill in the rest of the slope field if you want. Since we're just starting to sketch, we kind of get a decent idea. So we're going to go down, and depending on where we're at, we're going to get a couple different curves. It's going to look kind of nice. But that's what we want to do for our slope field. We want to start to look for structure, as well as, obviously, you can just plug in if you want. If I want that point, that's at 1, 2. 1 plus 2 is 3, so this would have a slope of 3. So you can obviously just plug them in too. So that's going to be our slope field. Same deal. We can check out another slope field, x over y. Again, the whole idea is to look for structure. So we're going to pick a point in xy coordinate pair, and then find out what our derivative is going to be. So in this case, if we pick 0 for y, we get an undefined. Now, AP doesn't like you to draw anything in, because technically you're not supposed to draw anything in. I like to put little vertical lines just to give me little placeholders to remind myself I haven't done it, but don't do that on the AP test. But it's good because it kind of helps to see the structure and see what's going on. So I'm going to do that. Again, this is just so we can see, just for learning purposes. So if the y coordinate is 0, we should get undefined slopes. So again, we're not supposed to put anything in there, but I'm going to put those in just for practice. If the slope, or sorry, if we have 0 and then y, we're going to get 0 if y does not equal 0. So here we're going to just get our nice flat line, slope of 0 slopes. So those are just going to go in pretty nice. And again, we can use our same idea. If the two things are the same, then we're going to get 1. Because 1 divided by 1, or 2 divided by 2, 1 divided by 1, anything divided by itself is 1. So these will all have a slope of 1. So we get a nice slope of 1 whenever x and y are the same. Whenever they're opposites, we should get -1. So again, we get -1 for all of these points. And we can see we can fill in the slope field actually pretty quickly once we realize some of the structure we're supposed to look for. As always, you're more than welcome to just pick 2 points. We'll pick 2, 1 in this case. 2 divided by 1 is 2. So 2, 1 should have a slope of 2. If you're astute, you'll see this will be a slope of 1/2 then. And again, you can fill out the entire slope field. You'll get some nice images. It'll give you a nice idea of what's going on. Now, remember, we're just using these red ones as practice. You don't want to draw in on the AP test. They'll mark it as wrong. For test if undefined. Because sometimes you do get a slope that looks like this, but sometimes it's actually undefined. Like you don't actually get a slope that's straight up. It could just be that value is also undefined, as we saw from first derivative to second derivative. Sometimes the second derivative was undefined, but the first derivative was also undefined, and that's why the second derivative was undefined, not because it actually gave you essentially an asymptote, which is what we're going to see. So that's my slope field for that one. So that's x over y. So that's what you want to do when you're sketching. So try and find equations that are undefined, make the equation 0, look for special axes, so we did for the x's and the y's. Look for any symmetries, so we did look for that, so we looked to see, hey, where was it the same in one place as the other? And then do you see any patterns? Diagonals are popular. So in addition to just going across the diagonals that we have, in this direction, we could also check out these diagonals to see if there's a pattern happening with those ones. because I believe with the x plus y, we do get something that will start to make a pattern if we go this way. So these should all have the same slope along the diagonals going this way, which would make that a little bit easier. So this, that all have the same slope. That doesn't look like the other green one. Those all have the same slope. And all along each of those diagonals, you'll get the same slope. So that's what to look for when you're sketching. So the other part is to interpret a slope field. The first thing you can do to interpret a slope field is just kind of look at it and say, all right, this is the example that I put on the overview. If we were to kind of connect these lines, they kind of look like they would make a circle. If we kind of visually say, okay, that looks mostly like a circle. So the equation is probably going to be x plus h squared plus y, not plus x minus h. We get our nice equation of a circle. Y minus h squared plus y minus k squared equals r squared. We see it centered at 0, 0, so x squared plus y squared equals r squared. And then the issue comes as to which circle do you want to pick? Well, if you pick this green one that I picked, looks like we've got a radius of 2, 2, so square root of 8. So it'd be x squared plus y squared equals 8. If we want to go out to these yellow ones, it looks like we've got a radius of 1, so it'd be x squared plus y squared equals 1. So again, when you want to go from a general to a particular solution, you can, but just interpreting a slope field, we want to get the equation, we want to see what the form is. Option 2 is to actually make sure that the differential equation gives you the listed slope field. So in this case, the easiest thing to do is to try and find anywhere where it looks like it's 0 or undefined. Well, here they don't have a line. So it looks like it's either undefined or they just printed it poorly. Well, the only way that that could be undefined is if y was 0 on the bottom, which would be this one, or if you couldn't plug 0 into the equation, so ln of y. However, we got a whole bunch of negatives for y's, so that's not what it is. There's other places where y is 0, so it turns out that this is not undefined. This is actually the way they printed it, is going to be a slope of 0. Now, it's important that we went over that because, again, if you're getting something that's printed, you need to be able to see, okay, even though it doesn't look like it's on that axis, it actually is directly on that axis. That's because for the AP test, they don't want you to draw on the vertical slopes. You have to make sure which one it is. So we have to make sure which one it is. So it turns out we want a slope of 0 at 0, 0. So again, now we can get rid of E and D because the slopes are undefined at 0, 0. At 0, 0 here, 1 plus 0 is not 0, so I wouldn't pick that one. 0 squared equals 0, 0 plus 0 equals 0. So it's really now between B and C. So it's either totally dependent on X or it's going to be dependent on X and Y. And we saw earlier when we had our one that was dependent only on X, I'm going to go back to that one real quick. Noticed if it depended only on X, all the ones that are vertical are all the same. And that is not true here. So we know it can't depend only on X. So we're going to get rid of the one that only depends on X. Because if it depends only on X, all in a column would be the same. Which is not true. It's not the case. So we can't pick that one. So we're left with C. We want to pick C. We get X plus Y. And does that kind of look like our X plus Y that we had started before? Yeah, looks like our diagonals. We said was going to be the same across the diagonals going this way. And it looks like that's true across those diagonals. So that looks like it matches up. The other thing is you might need to do a particular solution. So this is something that they could give you on the free response section of the test, is to actually find the curve that satisfies a certain point. The way to do it is to just go a piece of the curve by piece of the curve. So if we're at 6, 2, we want to find the one that goes through 6, 2, that's going to be this one. So what we want to do is we actually want to follow this curve essentially until we get to another one, and then we switch our slope, then we switch our slope. Here we're going to follow down, then switch our slope. And then, so these are all undefined, so I don't want to go past, which is kind of a little bit weird. I kind of want to make this go all the way like this, but I don't see anything. I can't tell if that's supposed to be a zero slope or an undefined slope. So it might look a little bit something like that. We'll pretend that that's a little bit dashed right there. For our solution at negative 4, 4, so again, we're going to start here and we're just going to follow it. Follow, follow, follow. And then again, we get to here. Maybe I will erase that so it doesn't confuse people. We get down to here, and it looks like that's going to be a vertical asymptote, so I should probably stop at that point. When we get to negative 2, negative 3, so then we're right there. Looks like we're good, looks like we're good, looks like we're good, looks like we're still good, looks like we're still good. We don't hit any asymptotes, we just kind of go up and then down. So that's our solution curve for negative 2, negative 3. Now again, it's entirely possible that the red curve continues on and goes this way. We're not sure. It's entirely possible that this negative 4, 4 continues along this way. But again, once we hit one of these asymptotes, we really can't go any further. We can guess it's going to be here and here, but we're not entirely sure. So that's our particular solution. So I do have a couple examples from the AP test. So here we've got this one, and I just wanted to show you just so you can see how they would ask these on the free response for the AP. Where you actually have to sketch a slope field. They actually give you the dots, and you actually have to make the slope field. You go through and you plug in your x's and your y's. So if we want to do a couple of these, we say this is 1, 1. So at the point 1, 1, dy dx is equal to 1 times 1 over 2 is equal to 1/2. So you draw a slope, that's a half right there. You don't need to write anything in there. Don't write in like m equals 1/2 next to it, because then your drawing's going to get a little bit confusing. You just want to go ahead and do that. Now this is a lot, but again, you want to look at your symmetries. You can see if anything is 0, if either x or y is 0, and you're going to get 0. So it looks like it's a lot of dots to fill out. But now all of a sudden we've done like a third of the dots. So that went by really quickly. So that's the idea for that. For B, it says let f be the function that satisfies the differential equation. Write an equation for the tangent line to the curve through the point 1, 1. Use a tangent line to estimate the value f of 1.2. So here it says write the equation for the tangent line to this. So we already know that the slope is 1/2 because we found that. We know the point is 1, 1. So we want to set up the equation using y minus y1 equals mx minus x1. So again, we got y minus 1 equals 1/2 x minus 1. And then just like when we did our linearization, this is what they're asking you. They're asking you to do a linearization with f of 1.2. So they want you to plug the 1.2 in for x. Y not equals y minus 1 equals 1/2 1.2 minus 1, and then you'd solve for y. So this is a linearization question. We did that a while ago. I think it was all the way back in Unit 3 we did some linearization. But this is where it'll pop up where we can see some of the things that we've done before show up again in the new sections. Then it says find the particular solution to the differential equation with the initial condition f of 1 equals 1. Use your solution to find 1, 2. So now they want you to go back and they actually want you to do a little bit more work with this. That it's going to be the stuff that we do in the next section where they want you to take the integral of both sides. Don't worry about that. That's in 7677. They actually want you to run through that whole process. So we haven't learned how to do this as of this video, but you do as of the next video. This is going to be diffie-q. We're just going to write that right there. Then it says to compare. So to find out which one is bigger, they want you to know which one's bigger, and then if it was an underestimate or an overestimate. It says use your slope field to explain why. So if we really quickly look at the slope field, if we put 2, 2 in here, we should get a value of 2. And since our slope is going to be increasing, since we're concave up, we can tell that we're going to have an underestimate because our slope is too low at 1, 1 to take into account what's going to happen at 1, 2. So we already know it's going to be an underestimate because the slopes are increasing. As x increases, and well, just as x increases is good enough. Obviously, you need to write a whole sentence on that. Don't just write those little notes. I think get your points. But I just wanted to go through the process and see, okay, here's where they're telling you to do this. So this is what you want to get in for your aspects. And I think that's going to be about it. I think there's another, nope, that's it. So it's going to be about it.